Hello, and thank you for watching this series of maths skills in biology. This is the fifth one in the series and the last one. Okay, so in this short section we're going to look at 6 questions. So the first question then, an enzyme denatures at temperatures, and you've got to be able to understand this sign. So this is greater than 45 degrees. It also denatures at a pH of greater than 8.8 or lower than 2.0. At a temperature of 39 degrees and a pH of 9.2, will the enzyme be denatured? And explain your answer. So first of all, I'm like, okay, so is it below 45 degrees? That's what I've said, because I want to make sure. Well, actually, yes, it is, because it's at 39 degrees. Is it above 8.8 as a pH? Yes, it is, because it's a pH of 9.2. So, yes, it will denature, and you can just say because pH more than 8.8. Or you could have said about the temperature. It doesn't matter, but I've just explained my answer. I've made sure I've given an explanation, even though I've shown it all there. Okay, so question 2. This one is looking at a graph and seeing if you can work out what's going on. The graph below shows the number of flowering plant species that are found at different altitudes. Describe the relationship between the number of flowering plant species and altitude. Whenever you see this term, describe the relationship, you should always mention both of the different variables. So you've got number of flowers, species, and you've got altitude. So all I've done is said there is a negative correlation between the number of species and altitude, because if you look, the pattern shows that it's working in a negative pattern. So I've mentioned both variables in my answer. I've given a really succinct answer, and I'll get the mark for that. Okay, question 3. In a food chain, plants take in 9,850 kilojoules of energy from the sun. Herbivores take in 897,000 joules of this energy from the plants. So I'm like, oh, okay, straight away they're trying to catch me out here, because I've got kilojoules there and I've got joules there. Calculate the percentage of the energy taken in by the plants that was then taken in by the herbivores. So first of all, I've converted this one to kilojoules to make it easier, and I've got 897. So now I've done 897 divided by 9850 times 100 equals 9.106. I've rounded it up to 3 significant figures, just in case the question asks that. This one didn't, but that's what the answer would be if it was. Okay, so question 4. Now you might think, well, you only have to work out circles and things like that when you do maths. But actually it does come up in biology as well, especially this. A scientist is testing for the effect of a new antibiotic on the growth of bacteria on an agar plate. If the antibiotic is effective, a clear area, and that's this here, the inhibition zone, will be left where the bacteria have died. The diagram on the right shows his results. Calculate the area of the inhibition zone, including the antibiotic, and give your answer to 2 significant figures. So again, don't forget to do this. It actually tells you the area of a circle, and it tells you what it wants you to use for pi. So the first thing I do is I measure my diameter of inhibition. So the fact that it's got a line there means it wants me to measure, and it's about 18 millimetres. So to work out the radius is 18 divided by 2 is 9. 3.14 times 9 squared equals 254.34. But I want this to 2 significant figures, so the answer is 250. That was for 3 marks, that question. Okay, question 5. Sophie was investigating the heights of pea plants in her garden. The histogram below shows her results. How many of Sophia's pea plants are taller than 105 centimetres? So first of all, I don't need any of that data down there. I've drawn a line to say, this is the data I need here and here. But you have to take account of the width here. So when you go from 105 to 110, it's telling me there's only one. However, you have to multiply that by the width. So that is 5. So 1 times 5 is 5. And this one, I've only got 0.1, but I've got 10 of them. So that's 1. 5 add 1 is 6. So that's how many plants are taller than 105 centimetres. And lastly, which class A to D is the modal height class of Sophia's pea plants? Which one's got the most plants? And if you worked out each of the bars, you'd actually find between 85 and 95, if I took it up to there and multiplied by how many are there, it's 1.4 times 10 is 14. So that is the actual answer. I hope you've enjoyed these little maths questions and good luck. Thank you.